Yeah, good morning, all participants, and congrats for joining our webinar today. And thanks for taking the time to spend that time with us. My name is Frank Krebs. I'm the commercialization manager at Avantor for equipment and furniture in Europe, and I warm welcome you guys. Just before we start, a little housekeeping notes. If you have any questions during the webinar, you're good to go to raise them in the question area. So we have a technical specialist aside at Julabo to answer all of your questions. And if that is a commercial question, I'm happy to answer them as well. You're on mute, so please use the question functionality as well as the chat functionality if you have a more common question to be raised. All materials shared in the webinar will be shared afterwards with you, including the recordings in our follow-up emailing. Sorry. So no need to write something down, or you won't miss anything during that webinar. The recording will stay at avantor.com and vwr.com for at least 1 year, and you are good to go to share that webinar with interested colleagues as well. With having said that, I welcome Gary Etherton from Julabo. It's your host today. He will put us through the presentation on how to choose the right chiller for your evaporator challenges you face daily. So thanks for taking the time, Gary, to pull us through today. And with that, the stage is yours. You're good to go.
Okay, thanks, Frank. Hello, welcome everyone. As Frank said, my name is Gary. I represent Julabo, and we make obviously a wide range of chillers, all offered through Avantor VWR. And what I wanted to do is today to talk briefly to you about selecting the right chiller. So we do over 20 different chillers of different sizes, whatever. And the question that we get most often from people is how can I decide which one, okay, to ensure that I get the results I want. So the first question I think you need to ask yourself is why you are getting a chiller. Why do you want a chiller? And there are in fact 4 main reasons. Okay, so the first is for environmental protection. A chiller does not use water, which is a resource which has an environmental impact. So a significant number of clients are saying, look, we want to save how much water we use, and so a chiller will do that because you're constantly recirculating the water. A second reason is to reduce the costs, because obviously mains water has a cost, and your guys responsible for your utilities are paying for that, and they may wish to save some funding in that particular area. The other thing you can do is obviously increase reproducibility, so the temperature of coolant coming out of a chiller is consistent, doesn't matter summer, winter, whatever. And the third one is to reduce flood risk. And I'll go through each of those very, very briefly before we move on to exactly how you can determine what size chiller you need. Okay, so let's talk about the protecting the environment. The EU published a paper on Europa.eu which said that there was a 24% reduction in renewable water across the entire EU. So obviously mankind is having an impact on how much water is available. It also has a carbon footprint as well. So a cubic meter generates roughly 10 kilograms of CO2 equivalent. Okay, so environmentally, using mains water does have an impact. The second reason is reduction of costs. Okay, so if you're cooling, let's say 2-3 evaporators, typical 2-3 liter evaporators, that is going to use the same amount of water as a typical 4-head household, which is a surprise to a lot of people, but that's a significant amount of water that can be used. And obviously almost everywhere you go these days is you have a financial impact of using water. So you pay for the water to come into your facility, and you also pay a sewage charge for water going out of your facility. So there is a financial payback of using a chiller. And the third one is increasing reproducibility. Now, it doesn't matter where you live, north, south, east, west, the temperature of your mains water is going to be different in the winter months compared to the summer months. And if you have a very temperature specific application, then obviously that can have an impact on the effectiveness of any condenser or the effectiveness of any experiment that you're doing that may use water. And finally is to reduce flood risks. And we've had stories from a number of laboratories where a bit of hosing has come off a condenser or a tap, and then that tap has ran over the weekend or overnight, and labs have been flooded and a significant amount of damage to that. Now, obviously, if you have a chiller, your hosing can still come off. However, a chiller will only have 3 or 4 litres of water, so the potential for damage of 3 or 4 litres compared to a tap running all weekend is significantly different. So what I wanted to do is just trigger a quick poll. I can see there's quite a few people here now, so I was going to get an idea of how many people actually use chillers and how many actually use mains waters. So if you have a moment, the poll is open. If you can just quickly fill in that, it will give an idea of how many of you guys are actually using chillers and how many are you running on mains water. I wanted to talk about
results coming in. Yeah, sorry.
Thanks, Frank.
Thanks,
Frank.
Or still coming in.
The results are coming in, but we'll get an idea of how many of you guys use chillers and how many use main waters. So typical applications and where we aimed this particular presentation to is obviously cooling condensers and cooling rotary evaporators, which is these days one of the most common applications. But to give you an idea, I personally have installed in chillers in diverse applications, such as one of the things that I installed on was cooling a thrust sensor measuring jet engines for defense applications. So tap water was used for many things, from glove boxes to cooling condensers and stuff like that. So the demand on those chillers can be very different. Sorry, go ahead, Frank.
Yeah, it's just to share your own results, Gary. It's very interesting to see that still 61% are still using main waters and just 39% are using already chillers. So I guess this webinar is great for them to help them to.
Yeah, and that is fairly typical of the labs we visit. Okay, so yeah. Roughly, 1/3, slightly higher, are using chillers. But that ratio is growing quite significantly. I would say 3 or 4 years ago, it was about 20%. So you can see that ratio is changing. So the key thing with these different applications, even the 3 pictures I've got there, you are going to need 3 completely different chillers. So the main question that we're trying to address today is, how do you correctly size the chiller? How do you choose which particular chiller to do? Okay, so there is a precise methodology. There is exact mathematics you can apply, but what I would say to you is apply the maths, and then it's a little bit of adding some margin for error. Okay, so the first step you need to take is look at the temperature. Okay, and a lot of people will come to us and say, oh, I'm running my rotary evaporator at this temperature. Forget the temperature of your rotary evaporator. What I'm talking about is of your tap water. Okay, the 3 things we need to know is the temperature of your tap water before and after the experiment and the flow rate through your device. Okay, so from that we can calculate the power, and I'll go on to some basic calculations. Okay, so the 3 things you need to measure: the temperature of water going in today in your tap system, the flow rate through your device, and the temperature of the water after the device. Okay, and from that we can calculate the power used. So I'm just going to trigger a second poll here. Quite often we get asked for what temperature to run the chillers. So the second poll I'm going to ask you is how many of you guys actually run your chillers below 4 degrees C? Or and the reason I ask this question is one of the things we get asked a lot for is, what's the lowest temperature of your chiller? And I would say to you that 99.99% of chillers replace tap water, and to the best of my knowledge, not much tap water goes below 4 degrees C. Yeah.
Yeah, just give the audience a second, Gary. It's coming in, but it already seems to be, more or less clear. 80% no and 20% yes.
Yeah.
So it's
Okay.
typical as well, I guess.
Okay, so the first thing you should know is that as a chiller manufacturer, okay, when we make chillers, we have some mechanical limits, and these will impact the financial cost that you pay for your chiller. And one of those big ones is 0 degrees C. Okay, so if you want to work below 0 degrees C, straight away your chiller is going to cost a lot more. And what I try and say to all of the guys we're sizing a chiller for is, if you're using tap water, you don't need to go below 4 degrees C. So that means you don't need an expensive chiller. You can have an inexpensive one. So that's a really good hint to ask yourself is, do you really, really need to go below 4 degrees C? So going back to what we need to measure, assuming you're running tap water at the moment, you can measure the temperature of tap water very easily. You can measure the temperature of the water after your condenser when you're using your rotary evaporator, so you can determine a delta T. And the next thing you need to measure is obviously the flow rate through your system. And this is something that can prove challenging for some people. And I would give you two really, really quick hints of what we do. The first is obviously a bucket and a stopwatch. These are fairly basic sciences to give you a flow rate, but it can be messy, it can be difficult, and a lot of people have challenges to do this. So what I would point you to is to Amazon or your local garden center. Each of our technical specialists carry one of these around with them. Cost about 20 quid or about 23, 24 euros on Amazon. And with this, you can measure the flow rate through your system. It's easy, it's dead easy to put on, it's inexpensive, and you get quite good numbers. The other thing you can do, obviously, is leave this on your system for overnight, over the weekend, over a week, and it will give you average data. It's only an estimate, it's not highly precise, but it does give you a good flow rate for the calculations. Moving on to the calculations, it's relatively straightforward from there. It's the standard, what you learned at school, the heat capacity calculations, which is, I'm not going to go into a load of maths for you here. If you ever have problems, you can contact Advanta Direct or us direct, and we can do the maths for you. But the maths is simple. The power required, and you can see in the second little box there, is change in temperature times CP, which is heat capacity, times mass, which is obviously your flow rate in kilograms, over time, and that will give you a power figure. So in this particular case, which is a case we calculated for a client, you can see that we have a delta T of 2 degrees through the condenser. Heat capacity of water is roughly 4.2. Okay, the flow rate was 0.06 liters per second, and from that we can come out with a capacity of 580 watts. So that's how much cooling you would require. My recommendation to any user is to add somewhere in the region of about 20% to that number for heat losses. Okay, so heat losses are in all your fittings and your connectors, and just to give you that margin. So if you come up with a number of 560 watts on this, I would not recommend a 560 watt chiller. I would recommend something in the region of 650 to 700 watts. Okay, so just always go up a little bit so you have that leftover margin. But again, there are two, even in the Ylaba range and with other manufacturers, you will tend to see a range of chillers. Okay, so you will tend to have, you can see that the Ylaba range is split into two, F and FL, and the variability comes not just from the power. So the F range is very, very simple, straightforward, very easy to use unit, goes up to 1 kilowatt, very basic unit. Okay, has all the, I'm not going to go into sales spiel, but what I wanted to do is to bring you onto the FL range, which are much, much larger, because the second thing you need to think about is flow rate through your system. Is obviously to remove heat from a condenser, you are going to need to flow the water through. So the F series, which is quite basic, has very simple pumps. It will pump quite happily through 1 or 2 glass condensers. But then if you're going into a bigger laboratory, one of the things you can do with chillers is attach different devices. So instead of having one chiller on every Rotavap, maybe you're going to have a medium-sized chiller that feeds 4 or 5 Rotavaps. So then you need to start thinking about pump capacity. So the main difference between families of chillers is not temperature. Yes, of course, it's power, but it's also the pump. Okay, so if we come on to this slide, I can give you a traditional rule of thumb on rotary evaporators, and that is each rotary evaporator typically, so I'm talking about 3 liters and below, okay, a rotary evaporator is typically going to need somewhere in the region of 250 watts of cooling. If you're doing your calculations and you get numbers that vary dramatically from that, check your data. Okay, so a 3 liter condenser, it's roughly 250, 300 watts. But obviously, if you've got some larger rotary evaporators, or you want to put 3 or 4 condensers all into one series, then you are going to need more cooling power. But what you're also going to need is higher pumping capacity, because this basic chiller with a pump can quite happily do 2 devices. It can probably do 4 devices. But if you go to 5 or 6, you are going to need to start thinking about pump capacity and the flow rate through the system, which would lead me on to the final poll of today, is to get an idea from you guys of how many of you are looking to go onto a single device, or how many of you are going onto multiple devices. In this way, I can talk about some of the things you need to think about when you are connecting more than one device. So the poll hopefully is now open. If you can give a second and just let me know roughly what you're thinking.
Yeah, it's open already for 20 seconds, Gary. Just harvesting the results.
So it's more and more common these days that we see customers who would like to buy a medium-sized chiller feeding 5 or 6 devices, rather than 4 or 5 chillers feeding individual devices. That obviously saves space, and it can save some capital investment as well.
It's nearly 50-50, Gary.
Okay, so a real mix there. Okay, which to be honest surprises me. My experience tends to be more and more people are looking to feed more devices, but 50-50, it's quite interesting. So I will go on now to some of the things you need to think about when you are connecting multiple devices to chillers. So first of all, you have to think about your pump, but also what you need to consider is to ensure that the flow rate through each device is equivalent, but also that each device is getting the same temperature. So you will need some sort of distribution device, like in these slides. There are 2 here. One splits into 2, one splits into 4, and these you need to consider these carefully to ensure that your devices are not collected in parallel, but to collect in series. And obviously that is to ensure that if you had 4 devices in a row, what you want to make sure is that all 4 of them are going to get cooled water at the same temperature, and you're not going to feed the water from your first device to your second device to your third device to your fourth device, so that your 4th device might end up with water at temperature 10 to 15 degrees higher than your first device. So that's the first thing you need to think about. The second thing you need to do is to ensure that the pump is up to the job. Obviously, if you're feeding 1 glass condenser, a simple 1 bar pump is dead easy. If you're feeding 4 or 5, you may need to think about a 2 or 3 bar pump. But also, I would remind you not just to think about pressure, but to think about flow rate. Most of chillers these days use centrifugal pumps, and the advantage with centrifugal pumps is they have some pressure and some suction. They're high flow rate, low pressure, which is very good for glassware, obviously, but also you can deadhead them without causing any damage to the pumps. One of the interesting things to think about is also the return on investment. Okay, so those people who are thinking, I'm using too much water, my water bill is too high. What is the return on investment on a chiller? Now, naturally, there are many variables here. So it depends how much you're paying for your water. Okay, it depends how much you're paying for your electricity, because a chiller will use electricity, and it also depends on the flow rate. But to give you an idea, our experience shows you that typically an return on investment on a chiller is about 2 years, or just under 2 years. Our average is about 19 months, okay? But it depends, each facility is different, each application is different, but here are the basic calculations that we use, and if you would like any help with this, I'm sure the guys at Avantor will help you to do these calculations. They're relatively straightforward, and it helps obviously you guys to justify any particular purchase. I think that is getting towards the end of what I had to say, but just as a quick summary, the 4 benefits of using a chiller are quite clear. Less cost, less environmental impact, greater reproducibility on your cooling water and your experimentation, and obviously reduced flood risk in your labs. The first thing you need to do is determine your power requirements, and that will give you a size, that will give you the indication of what size chiller you actually need to have. Okay, there are many different sizes available depending on the application, and if you need any help or advice, it's what we're paid to do. The guys at Avantor, the guys at Ylabo, we are paid to help you make the right decisions. And the final thing that I would say to you is ensure that you have equal flow when you're doing multiple applications. Many times we see the plumbing behind the chiller causing issues with downstream applications and elevated temperatures. So keep one eye on that particular variable. And finally, my one bit of advice to you is if you're not sure, it's our job to help you. We're here to help, happy to help all day, every day. And that is all I have to say. If you've got any questions or you'd like anything to discuss, fire them away at us. Frank, have you got anything you want to add here?
Yeah, thanks, Gary, already. So I'm just checking back again on the questions raised by the audience. So there was just one that is answered. Just coming back. And give it a second for any other questions. So, but that seems not to be the case, which means that you did great, Gary. So all questions answered in that way. But I really think that was great content and it was really helpful for our audience to decide on. I know from my sales past that I get from our customers exactly the same question. So I just underline what Gary said. If you have any questions left in your day-to-day business, come back to our staff at Avantor or to Ylabo and ask us any questions and for help in getting the right chiller for your rotary evaporator challenges. So that's for sure. We are happy to answer on that.
And the one thing, obviously, the one thing we're obviously going to ask you guys is, do you know the flow rate through your system and what's the temperature rise of the water through the system? Yeah. And if you don't know what it is or don't know how to measure it, obviously we have the kit to help you do that.
I just received a question, Gary. Would you recommend to have an open bath chiller to connect several condenser as well as using the bath opening?
You can do that, of course you can. To be honest, the most chillers that you see installed under a bench and the chillers that you saw in my images, they don't have an open bath on them, but that's purely and honestly for cost saving in the production side. Because an open bath chiller tends to be more expensive than an underbench one, because it has higher functionality, it has more things going on, it tends to have a heater in it. Which one's right for you? Completely up to you. Obviously, an open bath chiller would work just as well as one of these underbench ones. It has got a higher degree of flexibility because you can do experiments or put samples within the bath itself. But be warned that they tend to be a little bit more expensive. Because they tend to have a heater and probably slightly more sophisticated controller. So it's up to you, whichever suits you. Both will work.
Okay. So I just received is it normal the Presto series that you recommend for reactors? I guess that should be a yes, Gary, right?
Yes, that is a yes. The Presto series is slightly it's not a chiller as such. It's a lot more sophisticated. It has higher temperature range. A chiller that we've talked about today tends to its main job is to replace tap water. So it runs in a temperature of like 4 to 20, 4 to 50 degrees. A Presto will cover the range typically minus 50 to 200. So it's a different beast altogether. But yes, we would do that for controlling a reactor, whereas a chiller is obviously replacing tap water through something like a condenser, a rotary evaporator, or something like that. A chiller is designed to have static temperature for long periods of time at or around water temperature. A Presto reactor is obviously designed for more challenging applications where you're doing synthetic chemistry, for example.
I think it's also perfect for fast changing temperatures, right?
Yeah.
So to react on those changing systems. Yeah.
Exactly. Whereas the chiller is designed to maintain temperature constantly and not so much to change up and down.
Okay. So on top, I just received thanks. And do you have any type of recommendation when using Chillabo chillers with Rigaku instrument like Miniflex 600?
We have a lot of.
I don't know that system, Gary.
We have a lot of chillers on a lot of Rigaku systems, and they're very, very different sizes. So what I would say to you is, yes, we do. Okay, what we need to do is have a look at exactly what system you have and the specification of your system, and we can then share with you exactly which chiller we would normally recommend. But the Rigaku manufacture quite a lot of different systems of quite a lot of different sizes. So there are some quite big chillers. There are also some quite small chillers. What I would say is offline, have a chat with your Avantor guy, and he will network with us, and we'll say, look, this is what we've used in the past.
We'll give you that information, Elizabeth. Yeah. Offline. I will come to you offline. So. Okay, great questions, by the way, Gary. So
yeah,
really
good questions. Yeah.
So just to see if any additional questions appearing. Okay. That seems to be not really the case anymore. So yeah. I will then close the webinar with just the information beforehand that we will share. As said before in the housekeeping notes, the recording with you guys, it will stay at vwr.com for at least 1 year. You will get all the information shared through Gary, plus some brochures as well. So, and thank you for joining us today. Thank you, Gary, and have a great rest of the day. And we will now close the webinar. Thank you.
Thanks a lot, guys. Thank you very much. Bye-bye.
Thank you. Bye.